Welcome to Easy Math TV. Today we're going to calculate the average rate of change on a graph or given an equation of a function that happens to be a polynomial. So this is in our unit on quadratic functions and polynomial functions, but we're going to be talking about average rate of change. So it's also part of topic 2 as well, the topic on linear models, and then average rate of change was part of that topic. So we're kind of blending into those two topics here. And in the previous video to this one, we actually saw how to graph this equation in Excel. So this graph is something that we created in the previous video. And it showed basically just the shape of the curve and how it starts with high values of y, then comes down, 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 and then hits kind of a minimum value, and then increases to another peak here over at x equals 5. It hits another maximum, and then it goes back downward. So that kind of sideways S is indicative of, or it shows us that we probably have a third degree polynomial here, because it goes down, up, down. So that is a third degree polynomial, and you can see from the equation that the highest power of x is x to the third power. So that is what we call a cubic, or a third degree polynomial. All right, so that's just kind of a little bit of background on what we have in front of us. But what we want to do is, our goal today is to find the average rate of change between x equals -2 and x equals +6. So I've taken the liberty of labeling those 2 points on the graph. We have the point -2, -18, and we can actually see that from the table in a minute. And then we have the point +6, 70. So those are our 2 points. And I want to show you what the average rate of change actually looks like. We have to go to the Insert tab at the top, and we're going to put a straight line between those 2 points. So we're just going to insert a shape, and it's just a straight line. And hopefully we can get it to join those 2 points. If I need to move it down slightly, I will. We can adjust it like so. So that kind of looks about right. We can also, if we want it to be thicker or a different color, we can go up here and we can change the outline of it, or we can change the color. So I can make it orange, and I can also change the thickness. The thickness is called the weight, so I can actually make it a little bit more pronounced. So there you have that orange straight line is the line that connects the 2 points that we're interested in. What we want to do is we want to calculate the average rate of change, which is the slope of that line that we just made. Okay, the slope is going to be our delta y divided by delta x. Okay, so let's move this over to the side. And in my spreadsheet here that we created in our last video, we're going to take advantage or use some space that we have here in columns C, D, and E. And in cell C4, I typed the phrase average rate of change. So we just typed that into cell C4. And then because it's a lot of text, like the text is quite large, so I'm going to go up here and I'm going to merge cells C4, D4, and E4, because I don't want to mess with the formatting of the cells above it. Like, those I want to keep exactly the size that they are, and I don't want to make the heights of these rows any higher than they are, so I don't want to use word wrapping or anything. So basically I'm just going to stretch those words across cells C4, D4, and E4. And then I used my equation editor and I created another text box. So this is basically a text box here that you see. And inside that text box, I went to insert and chose the equation tool at the top over under all the way to the right of your insert tab. You'll either see the equation itself or you'll see the symbol sign, and then you can click on the drop down or the underneath symbol is also equations. So if you don't see the equation editor, it's underneath the symbol editor. So I put my delta y and my delta x, and then underneath that is delta y divided by delta x. So we're going to calculate those here in these three cells. I had to leave a space in between because it wasn't exactly aligned with the cell heights, so I just had to mess with it a little bit. So, just mess around with the formatting so that they're kind of lined up here. Okay. All right, so let's go back to the Home tab, and we're going to just color this in. I want to make it an obvious color, so let's make it orange. And then this is going to be orange also, and then this is also going to be orange. So those are our three values that matter. So as you can see, here's my table of values over here. And it starts with x equals -4 because that's what our instructions said. We were graphing it from x equals -4 to x equals +8. So those are all the values that we actually have at this point. And we are interested in what happens between x equals -2 and x equals +6. So what I think I might do is just go over here and change those colors to some kind of gray, just so that I know that there's my x equals -2, and here's my x equals +6. Okay. So I just want to kind of change the color of those cells so that I know exactly where my two y values are that I'm taking from over here. So this will be something that I'll probably want to undo or change later, but anyway. So delta y is going to equal, and we want to take the y value that we're interested in, the lower one, the one that's all the way down in cell B13. So I'm going to do B13 and subtract the one up in the upper B5. So equals B13 minus B5. Okay, that's going to be my delta y. Okay, and then delta x is, instead of column B, we're going to be in column A. So that's going to be A13 minus A5. So again, we want to make sure that we're subtracting in the same order. So if the delta y was B13 minus B5, then the delta x needs to be A13 minus A5 in the same order. Okay, and then our delta y divided by delta x is literally just going to equal, and then we want the number in D5, and slash we want to divide by the number in D7 in this case, because I skipped a couple of cells here because of the formatting. So delta y divided by delta x is going in cell D9, and it's equals D5 divided by D7. Delta y divided by delta x. So don't be alarmed if that happens to be a decimal value, because that is possible. But that 11 there is telling us what the slope of that orange line was that we made. So the orange line we made definitely has a positive slope. It is going upward from left to right, so that does make sense. So our average rate of change is, in fact, I'm going to copy and paste over to here. so that my average rate of change is showing as 11. So that is my answer to the question. Find the average rate of change between x equals -2 and x equals +6, and the answer to that is 11. So that means that y is increasing on average by 11. It's going up 11 for every time that x increases by 1. Y is going to increase by 11 on that, just on that interval, on average. Okay? So like, subscribe, comment down below, share these videos with other people if you think they'll find them useful. And that is our discussion of average rate of change of a function on an interval.